Hello team. In the previous video, you saw how operating systems manage the hardware to isolate one application from another and to prevent malicious applications from taking control of the computer. Now, virtualization has the same problem. So the operating system that's running on a virtual machine will need to control the hardware to isolate applications, but we cannot give the operating system running on the virtual machine complete control of the hardware. Otherwise, the kernel on the virtual machine would be able to hijack and take control of the hardware. So this is a fundamental problem in virtualization. So let's see how paravirtualization, the topic of this video, deals with this. So in paravirtualization, a server runs a hypervisor and their hypervisor runs in ring 0. So the hypervisor has complete control of the machine. The hypervisor runs many VMs and we are going to modify the guest operating system running inside the virtual machine so that the guest operating system runs in ring 3 without any privileges. So the guest operating system will have partial control of the hardware, but whenever the guest operating system needs to reconfigure the hardware, say to perform an input-output operation or reconfigure the memory management unit, the guest operating system will ask the hypervisor to perform these operations on its behalf. So the guest operating system and applications running on the guest operating system inside the virtual machine execute native code, that is Intel x86 code. So there's no emulation, and these applications and the guest operating system run very fast. So we achieve high performance because there's no emulation and no translation. One thing we need to do, however, is to rewrite privileged instructions in the guest operating system so that instead of calling the privileged instructions directly, the guest operating system will instead ask the hypervisor to perform the privileged operations on its behalf. Rewriting the privileged instructions to call the hypervisor instead does incur some overhead. So instead of just executing one instruction, the guest operating system will call a function on the hypervisor, and then the hypervisor will verify that the guest operating system has no permissions to perform the operation once. And then if the guest operating system does have the permissions, then the hypervisor will do the operation the guest operating system requested and return control of the CPU to the guest operating system. So this incurs some overhead, but most of the application code and the guest operating system code does run natively, so we do get high performance most of the time. Unfortunately, the biggest problem with paravirtualization is the need to modify the guest operating system, and this may be very hard. First, operating systems, they use privileged instructions in many different places, so we need to adjust all of these. And some operating systems are closed source, say Windows, so they're very hard to modify.